So, good morning, everyone. It's a great honor to present our study on one of the most critical aspect of high-speed propulsion system, that is the design and performance optimization of supersonic inlet for ramjet engine. So, as we progress into an era where hypersonic and supersonic technologies are reshaping the future of aerospace and defense, efficiency of propulsion system plays a vital role. So, among the key components enabling this technology advancement is the supersonic inlets, a crucial system that ensures efficient air compression, pressure recovery, and stable combustion at high max speed. So, today our team, me, Prajakta, and Prachi, will take you through a comprehensive analysis of how supersonic inlet function and their importance in ramjet propulsion. Uh, Also, the different type of supersonic inlet and their unique characteristics, key design factor that influence their performance. Likewise, so through this presentation, we aim to provide uh, insights into how the cutting edge engineering solutions are improving the supersonic inlet efficiency, making next generation aerospace vehicles more powerful, reliable, and fuel efficient. So let's begin with what is ramjet engine and how it works. So a ramjet engine is a type of air breathing jet engine that operates at high speed, typically above Mach 2, so without any moving part like a compressor or turbine. Instead, it relies entirely on forward speed of the aircraft to compress the incoming air before the combustion. So now this brings us to the supersonic inlets, the one of the most crucial component of ramjet engine. So, unlike the conventional inlet, supersonic inlets must slow down at high speed incoming airflow efficiently before it enters the combustion chamber. So, this process is vital because combustion in ramjet engines requires subsonic airflow for stable fuel burning. So, thus, the primary role of supersonic inlets are slowing down the incoming supersonic airflow to subsonic speed while minimizing the energy losses, uh, and managing the shock wave efficiently to maximize the pressure recovery, ensuring smooth and stable airflow for optimal combustion efficiency. These are the primary roles. So the design of supersonic inlets is complex and involves aerodynamic shaping material material selection, and shock wave control techniques to maximize the efficiency while minimizing drag and losses. In the next section, we will explore the different type of supersonic inlets and their advantages and challenges. So, as we explore this topic further, we will cover the classification of supersonic inlet, key design consideration, advanced performance optimization techniques. Likewise, so let's begin by discussing the different type of supersonic inlets and their working principles.
Three types of the supersonic inlet. First one is the internal compression inlet, second one is the external compression inlet, third one is the mixed compression inlet. So talking about the internal compression inlet, a supersonic air intake where the airflow compresses the inside the inlet and using the shock waves is called as the internal compression inlet. The internal compression inlet have the high efficiency and the magnetic is high, and this engine is used in the high speed aircraft and also the engine like the ramjet. So second one is the external compression inlet. The external compression inlet, the supersonic air intake where the airflow compresses and slowed down outside the inlet using the shock wave for extending the engine. You can see the internal compression inlet, the airflow compresses inside the inlet, but the external compression inlet, the airflow compresses outside the inlet using the shock waves. Is called the external compression inlet. So this inlet have the high efficiency and the supersonic speed is high, and this inlet used in the high speed aircrafts. Also this inlet used in the SR-71 Blackbird aircraft. This inlet used in that aircrafts. So third way talking about the some shock waves inside the inlet. It's called as mixed compression inlet. The mixed compression inlet have high efficiency and the wide magnetic is high. So this inlet is used in the some aircrafts like the 1FR 14104 and the Conqueror. So these three types of the inlet of the supersonic inlet.
Hello everyone. Now I am going to talk about the key considerations for supersonic inlet in ramjet engine. First, inlet geometry and material. The shape of inlet, whether it's a wedge or a conical design, is crucial for efficient airflow compression. It must be also be made from heat resistant materials to withstand high temperature and intense aerodynamic forces at supersonic speeds. Then next is shock wave control. When air enters the inlet at supersonic speed, it must be slowed down using a series of oblique and normal shocks. Proper shock management ensures a smooth pressure rise while minimizing energy losses and preventing the airflow disruptions like inlet unstart. Then next is mass flow regulation. The amount of air entering the engine, it needs to be controlled for stable operation. This is done using adjustable ramps, then doors or bleed systems are also there, which helps maintain optimal airflow across different Mach numbers. And finally, pressure recovery efficiency. The goal is to maximize the pressure gain from the inlet while minimizing flow separation and energy losses. A well-designed inlet ensures that enough compressed air reach the combustion chamber for efficient fuel burning and thrust generation. Talk about some performance optimization techniques that are used in supersonic inlets to improve efficiency and stability. First is variable geometry inlets. These inlets adjust their shape using movable ramps, doors, or spikes to optimize airflow at different speeds. At lower speeds, the inlet remains open to allow more air in, and while at higher speeds, it adjusts to control compression and prevent excessive drag. This adaptability ensures efficient operation across a wide Mach range. Then talking about bleed systems, these are used to remove low energy boundary layer air or excess airflow that could cause flow separation inside the inlet. By strategically bleeding off unwanted air, we can improve pressure recovery and maintain stable performance. Without bleed systems, flow disturbance could lead to efficient losses and unstable combustion. That's why bleed systems are important. Then next, now CFD simulation and wind tunnel testing. Before testing in actual flight condition, engineers use computational fluid dynamics, that is CFD, simulations to analyze how air behaves inside the inlet. This simulation helps to visualize shock wave interaction, pressure distribution, and potential areas flow separation. Then, after CFD analysis, wind tunnel testing is conducted to validate the results, ensuring the design performance efficiently under real aerodynamic condition. This combination helps refine the inlet design before full-scale implementation. And the talking about final one, which is shock positioning and control. Managing the location of oblique and normal shocks is crucial for efficient pressure recovery. If the shocks from too early or too late inside the inlet, they can cause energy losses and unstable airflow. To prevent these, techniques like adjustable ramps and internal flow control help position the shock in desired location. Proper shock management ensures smooth compression and stable airflow into the engine, enhancing overall performance. Thank you.
In compressing incoming air efficiently for the high-speed ramjet engine. K-design improvement the focus on managing shock waves, ensuring the flow stability, and the selecting suitable material. So supersonic inlet are the essential for efficiently air compression ramjet engine. Final and also the key design of the improvement focused managing shock loss, ensuring the full flow stability and the